Right. We'll start looking at this next section. It's chapter 12 of your textbook, oxidation numbers. Now we'll do it rough and ready. We would have went through it slower, linking in chapter 5, going through oxidation reduction. But anyway, so far what we've looked at is acid-base reactions. So if you think of your titrations, you're looking at your vinegar, say your ethanoic acid with sodium hydroxide, your sodium carbonate, and say your hydrochloric acid. And what that involved was a transfer of protons, linking into arrhenius acid and a Bronsted-Lowry acid, all them definitions. Now what we're going to look at is redox reactions. Redox reactions look at transfer of electrons. Now what that RED bit stands for is reduction, and what the OX bit stands for is oxidation. So before we looked at transfer of protons, or H+, now we're looking at transfer of electrons, those negatively charged electrons. Now there's a few definitions that are very important. You could just pause the video here once we finish chatting through them, fill them into your notes. I'll tell you where to go with them. But these are all the definitions on the leaving cert basically for this topic. So the first one here is oxidation, or in terms of electron transfer, so where the electrons go. So if they lose electrons, it's known as oxidation. So oxidation is the loss of electrons, and we remember that by the term oil. Reduction is the gain of electrons. Remember that by the term rank. So you have to learn each of these word perfect, I'm afraid. So if they ask you to define oxidation in terms of electron transfer, you say oxidation is the loss of electrons. Second one is in terms of oxidation number, and we'll meet oxidation number in this lesson here. So if you lose electrons, if you lose these negative charges, obviously you're going to become more positive. So oxidation is an increase in oxidation number. And if reduction gains electrons, gains these negative charges, then it's going to be a decrease in oxidation number. And if you think of price, if a Man United shirt was reduced, then the price is obviously decreased. So reduction is a decrease in oxidation number. And then there's these two agents. Again, very important definitions. An oxidizing agent is a substance that allows oxidation to happen by gaining electrons itself, and any substance that gains electrons is reduced. So in order for a substance to lose electrons, some other substance must gain them. Yeah, so that's what an oxidizing agent does. It gains the electrons, allowing another substance to lose them. So it's an agent allowing oxidation to happen. A reducing agent, substance that allows reduction to happen. How will it allow something to gain electrons? It'll lose electrons itself. So that reducing agent, that one substance that loses electrons, is known to be oxidized. So pause. I'll give you these in the notes, you fill them in, you learn them. And then the last thing that we'll be looking at today is oxidation number. It's the charge that an atom appears to have when electrons are distributed according to certain rules. So pause it here, fill them in, and maybe learn them for today, and then these the next few days. Right. Rules for assigning oxidation numbers. This is kind of your go-to. You will get used to them. So group 1 elements, your alkali metals. So they're like sodium, lithium, sodium, potassium. They've got all one electron in their outer shell. What do they want to do, the way I think about this, to become stable? They want to lose electrons. They want to lose one electron. They lose one electron, they're going to have a charge of +1. So if they lose one electron, they're going to have a charge of +1. Group 2 metals, my alkaline earth metals, they have 2 electrons in their outer shell. So what do they want to do? They want to lose them 2 electrons. If they lose 2 of these negative charges, they're going to become +2. So group 1 elements have an oxidation of +1. Group 2 elements or metals, say like calcium, has an oxidation number of +2. And once we do a heap of examples, you'll start getting the hang of it. Hydrogen, a lot of the times you'll see it in above your group 1 metals, even though it's a gas. Generally, I'll use that word, generally has an oxidation number of +1, except when it's bonded to a group 1 metal, so like sodium. So sodium then takes preference, takes trump. So it'll be your +1, so it'll be your 1 here. Or group 2, and we'll show a few examples in this. Oxidation or oxygen is a group 6 element. So in order to get a stable configuration, it generally gains 2 electrons. If it gains 2 electrons, it's going to have an oxidation number of -2, except in hydrogen peroxide, where your hydrogen takes trump. And we'll show you how you fill these in. So hydrogen here, each hydrogen has an oxidation number of +1. There's 2 of them. Each oxygen then, since that's neutral, it must go back to 0. So 2 times +1 is 2. That'll be 2 times -1. Each oxygen has an oxidation number of -1. Don't worry, we will go through these more slowly after a while. And in fluorine, because fluorine's more electronegative, since it's more electronegative, it'll always have a greater pull of the electron. If it pulls the electron closer to it, it's going to have an oxidation number of -1. So it's a charge that an atom appears to have. There's 2 of these fluorine atoms, so that's what the 2 outside them goes. And since they're only looking at position of electrons, we write them in below. So 2 times -1 is -2. That means your oxygen must be +2 in that case, as I say there. Halogens, so they're group 7. Group 7, how do they gain noble configuration, noble gas configuration, or stable configuration? They gain 1 electron. They gain 1 electron, they're going to be -1. So they kind of match up to your valencies. Your group 1's 1, your group 2's 2, your group 7's 1. It's just with your charges. If they lose electrons, it's going to be +1. If they gain electrons, it's going to be -1. If they gain 2 electrons, -2. Chlorine is -1 because it's a halogen, except when it's bonded to oxygen, or fluorine. So when it's bonded to oxygen, your oxygen takes trumps. So oxygen's -2, as we said up here, bar them few exceptions. So chlorine, in order to bring it back to 0, is going to be 2 times +1, sorry. So that's +2 -2, it's 0. And oxidation numbers add up to the charge in the molecule. So if we're looking at, say, potassium manganate 7, here, one of your properties of transition metals is variable valencies. So you start with your oxygen. How many oxygens are there? There's 4. What's the charge of each oxygen? -2. So that means we're at -8. We want to get it to -1 because of this charge here. -8 to -1. That means your manganese must have an oxidation number of +7. Same here in our NaH, and we fill it in as well. Na, it's a group 1 metal, so it's +1 because it loses 1 electron. Hydrogen matches up to the charge on it. There's no charge on it, so it's neutral. So that must be -1. Oh. Yeah, so sodium +1, hydrogen -1. Right, I'll do examples in this, and it will start sinking in after a wee while. So what is the oxidation number of the following? So they've asked you in this from your examples and your notes, what is the oxidation number of phosphorus and H3PO4? Now I always start with my oxygen. Oxygen has an oxidation number of -2. How many oxygens are there? There's 4. So 4 times -2. Hydrogen then has an oxidation number of +1, and there's 3 of them, because remember it's a charge that one atom appears to have. So I've got -8 +3, and I want to get it back to 0. So -8 plus 3 is -5, so that must be +5. Therefore, phosphorus, since it asks in particular, is +5. Next one, KMnO4. They've asked you for the oxidation number of manganese. So again, I see my oxygen. It's not one of the exceptions. I fill it in from there. Oxygen is -2. There's 4 of them. Potassium, it's my group 1. Group 1 metals want to lose an electron. They lose 1 electron, their charge is going to be +1. So we're at -8 plus 1 is -7. It wants to get back to 0, so it must be +7. So they always cancel out. So Mn is +7. Here now, glucose, C6H12O6. Again, I see my oxygen. I'll start with that. That's just always my go-to. 6 times minus 2. Got my hydrogen, I can fill that in as well. It's going to be 12 times plus 1. So 6 minus 2 is minus 12. 12 times plus 1 is plus 12. We're at 0. And then we've got 6 of these carbons. So that's going to be 6 times 0. Because the charge, there's no charge overall, unlike in this one. So they add up to 0. Now I've got nitrate, NO3 minus. Again, I've no rules for nitrogen. I've got ones for oxygen. Start with that. 3 times minus 2. We're at minus 6. We want to get it to minus 1. So they sum to the charges on the molecule. So minus 6 to minus 1. What do? We add on 5. If that was, say, NO3, say there was no charge on it, you'd go 3 times minus 2 for your oxygens, minus 6, and you're going to 0 because there's no charge on it. So your nitrogen would be plus 6. So therefore, your bottom one here, you've got your oxygen, your go-to, 3 times minus 2. Your sodium you can also work out, it's group 1. Group 1 have charges of plus 1, and there's 2 of them. So minus 6 plus 2 is minus 4. You must get on another 4, so 2 times plus 2. Because there's 2 sulfurs, that's what that 2 means, and then the charge of each of the sulfurs is plus 2. So if I tally them up, I've got 2 plus 4 minus 6, look at that, they cancel because there's no charge on it. Looking at copper sulfate, CuSO4. Oh, this is difficult. You'll see why now actually. So CuSO4, this is actually a tough one. Generally I would say start with my oxygen. Mightn't have enough space now. 4 times minus 2. Now I don't know these ones. There's no kind of set rules for my transition, metal copper, or for sulfur. So I've got to work with something else. And this SO4, these is an example of a radical. So if you look at sulfate, SO4, remember 4 times 2 is 8. So your charge of sulfate is SO4 2 minus sulfate. 4 times 2 is 8, sulfate. So there's 2 ways you can do this. You can work with this individually. So say my sulfate, that's 4 times minus 2. I'm at minus 8. I must get to the charge on it. How do I go from minus 8 to minus 2? I add on 6. So sulfur has a charge of plus 6. And if sulfur has a charge of plus 6, if we fill these in, 4 times minus 2 plus 6 minus 8 plus 6 is minus 2. Copper must be plus 2. Someone else might have said, I'll do it over here, CuSO4. So anything with a radical, or if you can never figure out 2 elements, then maybe a radical's hidden away in it. So someone might have realised that sulfate is SO4 2 minus, so that Cu must be 2 plus in order for that to cancel. Now you're still going to have to work out your sulfur individually then. Now back to normal ones here. Na2S4O6. So again I see my oxygen, so it's 6 times minus 2. Sodium I can work with as well, we've got rules for that. It's group 1, so it's 2 times plus 1, so it's minus 12 plus 2 is minus 10, and you must get that to 0, so you have to add on 10. Now there's 4 atoms, 4 into 10 goes 2.5. 4 times plus 2.5. Now you know you're not going to lose 2.5 electrons, but it's a charge that an atom appears to have. General rules. It just helps identify what's oxidized and what's reduced when we get on to equations. Therefore sulfur is equal to plus 2.5. KClO4. Oxygen again. This is from your questions now. A few wee questions, 1, 14, 17. And then I've made up a few more examples. So KClO4, see my oxygen, start with that, 4 times minus 2. I've got potassium, which is group 1, that's plus 1. And now your Cl minus 8 plus 1 is minus 7, so KCl must be plus 7. Yeah, your alkali metal takes preference here when you're filling that in over your Cl. So work with that first. Another tough one. I2, just a strange one. This would be the same for I2N2O2, whatever. So it's charge that one atom appears to have. There's no charge on it. It's neutral, so it's going to be 2 times 0. Same in all of these, if you like. 2 times 0. Here's one of the exceptions, hydrogen peroxide, H2O2. Your hydrogen takes preference. As I said there in this rule, not in this rule here, oxygen has an oxidation number of minus 2, except in H2O2 where it is minus 1, because your hydrogen is trumps here. So 2 times plus 1, and then my oxygen must be 2 times minus 1. OF2, another exception. Question 10 in your notes. Fluorine's the most electronegative atom, so always has the pull of the electron. So fluorine is going to be 2 times minus 1. That's going to be 2 times minus 1. We're at minus 2. We must bring it to 0 because there's no charge on it. So my oxygen must be plus 2. OH minus, my hydroxide. So it just must sum to the charge. Actually, these both work out to what they generally do. Oxygen's minus 2, hydrogen's plus 1. Minus 2 plus 1 is minus 1, which is the charge in it. H2O, my water. Say there's my 2 times plus 1. Again, there's no charge in it. So plus 2, you want to get it to 0. Here's my minus 2. And the last one here, Cr2O7 2 minus. Transition metal, variable valencies. Don't know what to do with them. Oxygen we do. 7 times minus 2 is minus 14. You want to get it to minus 2. What have you done there? You've added on 12. And that's going to be split among 2 atoms. 2 times plus 6. Therefore, chromium is plus 6. So if they do ask you individually what is a certain element's oxidation number, always just write it at the end as well. Keep it easier for the examiner. Perfect. Now you try actually them questions and list them up. Go back over these examples. It will take a wee bit of time getting used to, but the more you do, the easier it'll become. And if there's any questions, let me know.